Hi everyone, we're going to express each decimal as a rational number in the form of a divided by b. Basically, this video is based on what my students were saying off of previous videos that I did on this. So basically, we're going to do this one and this one. And what I did in the previous videos is I wrote this out as 0.49 plus 0.009 plus 0.0009 plus ... and so forth. And they didn't understand where I came up with that. So basically I'm going to explain that part and then find the infinite sum based off the infinite geometric series formula. So basically let's look at the first one. We have 0.49, repeating is the 9. And this equals 0.499999 and 9, and it continues on and on. Therefore, the way I'm going to write this, if I go vertically, is going to be 0.49 plus 0.009 plus 0.0009 plus 0.0009. Whoops, need another 0. 9. Okay, and when you add all that up, you get this. So therefore, that's why I wrote this as 0.49 plus 0.009 plus 0.0009 and so forth. Also, since we're doing the infinite geometric series formula, which is this one, I have to get the common ratio. There's not a common ratio between these two and these two. However, there is a common ratio between these three. So what I'm going to do is not use this one and just find the common ratio for these three, or basically these two, and then add this part at the very end. So if I do my common ratio, you can either use a calculator or you can just do this one. Let me do it on the next slide. So basically now I'm going to go ahead and write it. We have 0.49 plus 0.009 plus 0.0009, and we keep adding an extra 0. And if I write this in fraction form, I'm not going to look at this one, I'm just going to look at these. And you take the current term divided by the previous term. I'm going to write this out as 9 over, and I have 4 zeros here, so 1, 2, 3, 4, divided by this one, which would be 9 over 3 zeros, 1, 2, 3. Now when you reduce this, we're going to cancel out the 3 zeros. The 9's cancel, and so my common ratio is 1 over 10. Now, all I'm going to do is take my first term, and I'm counting this one as my first term, and this one is my second term. So I have 9 over 1,000 divided by 1 minus 1/10, using my formula. So this is my first term right here, and I'm subtracting 1 minus my common ratio. This is going to be 9 over 1,000 divided by 10 over 10 minus 1 over 10. And this is going to give you 9 over 1,000 divided by 9 over 10. 9's cancel, these zeros cancel here. So you get 1 over 100, which equals 0.01. And then I have to add this back in, so this is plus 49, and this gives you 0.5, 0.5 or 1/2. Okay? And the second one we're going to do is 0.01. 0.28 repeating. So 0.28 repeating, which equals 0.28888 and 8 and so forth. So writing vertically, this would be 0.28, 0.008, 0.0008, 0.00008, and if you added these all vertically, you would get 0. And you put the 28, then you have this 8, then you have this 8, then you have this 8. So again, we're going to use add this part last because the common ratio is not the same. The common ratio is the same for this one. It's the same as last time. We're multiplying by 1/10, and I can write it out horizontally. This would be 0.28. I'm just going to leave that to the side. Then we have 8 over 1,000 plus 8 over 10,000 plus 8 over 100,000, and you can see that r is just 1/10. Therefore, when I use my infinite sum formula, I get 8 over 1,000 divided by 1 minus 1/10, and that's going to give you 8 over 1,000 divided by 9/10. And that's going to give you 8 over 900. And then we have to add this number here. You add this number here, 0.28, and use your calculator. You hit math, enter, you're going to get 13 over 45. And if you write it in the form of A over B. And that's all. Thank you. Have a nice day. Bye-bye.